before we can begin to understand the sine function, we need to look at two special triangles. So here they are. They're both right angle triangles. Now, where do these triangles come from? One of them is derived from an equilateral triangle. So you can start by taking an equilateral triangle of three sides of one unit. Okay, so equilateral means three of the sides are equal, which results in having three angles that are equal, and they are 60 degrees. The other triangle comes from an isosceles triangle having a right angle. So that leaves us with two angles of 45 degrees, and we are setting the hypotenuse to 1. Okay, so if you start out with these two triangles, you can get your two special triangles. So let's start by looking at the equilateral triangle we have over here. Okay, so if we take a look at only one half of the triangle, so we slice it right in the middle, that will create an angle of 30 degrees at the top, and we can look at the base of one half. Okay, we're only looking at the triangle that is to the right here, so we can slice this equilateral triangle in half and discard one of the sides. Okay, so we're only going to look at this side here. So we have a side length of 1. Okay, our base at the bottom is now 1/2 because we divided it in 2, and we have the angles of 60 degrees and 30 degrees. Okay, so we can find the third side length B by using the Pythagorean theorem. So we remember the Pythagorean theorem, a squared plus b squared equals to c squared. So we can substitute the values in there. Okay, so we have 1/2 squared plus b squared equals to 1 squared. We want to solve for b, so we want to isolate b squared first by bringing the 1/2 square to the right side of the equation. We can simplify that right side now. So 1 squared is 1. 1/2 squared is the same as saying 1 square over 2 squared. So that's going to give me b squared is equal to 1 minus 1 over 4. I want to subtract, so I must put my terms on a common denominator. So 1 is the same as 4 over 4. So we can find b squared is equal to 4 over 4 minus 1 over 4. That gives me 3/4. Okay, b squared is equal to 3/4. So that's going to give me b squared is equal to square root of 3 over 4. And that's the same thing as saying square root of 3 over square root of 4. We know the square root of 4 is 2, so our denominator now becomes 2. Okay, so we found the value of b, which is square root of 3 over 2. Okay, so here's our first special triangle. It has one angle of 60, one angle of 30, and the three side lengths, 1, 1/2, and square root of 3 over 2. So if you forget these numbers, they can very easily be derived by starting from here. So you just start from here and slice your equilateral triangle in 2, and then with the use of the Pythagorean theorem, you can find your special triangle. That's the first one. The second one, you start with an isosceles triangle of a hypotenuse 1. So an isosceles triangle has two equal sides. Okay, so here we chose to have an isosceles triangle that is a right angle triangle. So we have this 90-degree angle, which means that these two angles here are 45. Okay, now if we look at our isosceles triangle, we can use the Pythagorean theorem in the same way that we did for the other triangle. So here we have a squared plus b squared equals to c squared. In this case, both sides are equal. So I can say b squared, if I called this b, I can call this side b as well. B squared plus b squared is equal to 1 squared. Okay, b squared plus b squared, that's 2b squared. That's equal to 1. And we can isolate b squared by dividing by 2. Take the square root on both sides. That's going to give me b is equal to square root of 1 over square root of 2. Square root of 1 is 1. So we have b is 1 over square root of 2. Okay, and that's our second special triangle. Sometimes you see it differently. You see it looking something like this, square root of 2 over 2 instead of 1 over square root of 2. It's the same thing. You can see here, if I have 1 over square root of 2, that's the same thing as saying 1 over square root of 2 times square root of 2 over square root of 2. I'm just multiplying it by 1 here, so it doesn't change the value. And that will give me a numerator of square root of 2. My denominator becomes square root of 2 times square root of 2. That's the square root of 4, which we know is 2. So that gives us square root of 2 over 2. So sometimes instead of seeing this 1 over square root of 2, you see square root of 2 over 2. Okay, so don't get confused. It's exactly the same thing. Okay, for our purposes, we'll usually use 1 over square root of 2. Okay, so remember this gives us our two special triangles, which you can memorize but also easily derive by starting off with your equilateral triangle and your isosceles triangle. Now, why are these special? And we've chosen a side length of 1 in our equilateral triangle, and we chose a side length of 1 for our isosceles triangle. Why did we do that? Later on, we're going to want to fit these triangles in what is called the unit circle. You see this, we can see part of the circle over here. Okay, it has a radius of 1. Okay, so we want to fit our triangles in this unit circle. That's why we chose these sides of 1. Okay, we'll see that later on.